Okay, this is the second part of the video. We're still on question number 2 on your study guide about Anna and her pens and a backpack and pencil. Okay, so it says, what is the probability? We're on 2C. What is the probability Anna will use a black pen? Okay, so what is the probability that Anna will use a black pen? So let's look at our area model. Okay, here's our black pen. I'm sorry, black pen's right here. It's 1/5. Okay, so the probability that Anna will use a black pen is 1/5. Again, percentage, that's 20%. As a decimal, that's 0.2 or 0.20. No percentage sign, okay? Or you can write a ratio 1:5. Now, what is the probability that Anna will use a pen and an eraser? Well, here I have black pen, blue pen. Here I have pencil and eraser. No times do pens overlap with erasers, so they don't overlap at all. Okay, so the probability of pen and eraser is 0 out of 5, or you can say 0%, or you can just say 0 or 0 to 5. Either one is okay because they don't overlap at all. Okay, it says Anna is Anna equally likely to use blue pen, black pen, or pencil today? I think your study guides say pencil or eraser. Okay, either way, it's going to be the same thing. Okay, no, because they have different probabilities. And I'm just going to list them just to make sure that I'm clear about the differences. So the probability of blue pen is 1/5. Probability of black pen is 1/5. These are equally likely to each other, okay? But the last one, the probability of a pencil or pencil eraser, okay, is 3/5. So these two are equally likely to each other, but the three of them together are not equally likely to each other. Okay. All right. Pause it if necessary. Replay it, rewind it, whatever it might be. Okay. It says for number 3, Alex has a bag containing 1 green marble, 1 blue marble, 1 red marble, and 1 yellow marble. Here it says, besides the color of the cover, that's just a typo. It doesn't need to be there. Alex's bag also contains 1 coin that he will toss either heads or tails. Okay. Alex conducts 12 trials. Okay. Because it's 12 trials, this here means experiment. Okay. That is his experiment. Okay. He conducts 12 trials or an experiment, randomly pulling out 1 marble and flipping a coin. Here are the results of her experiment. Or his. Alex can be either one. What is the theoretical probability that he draws a blue marble or flips heads? Okay, so what I'm going to do is I'm going to do this 2 ways. One, I'm going to do this using the area model. Okay, so here's my area model. Okay, and I kind of skewed it a little bit because my first event has 4 options, I think. Green, blue, red, yellow. So it has 4 options. Green, blue, red, and yellow. So that's why I made this one a little bit longer, so I had the space. My second event was heads or tails. So what I'm going to do is I'm going to break this down equally because they all have an equal chance. Because there's 1 marble of each, there was no 2 green marbles and 1 blue. So they all had 1 marble each. They have equal chances or equal likelihood. So the first question says, what is a theoretical? Theoretical is based on this area model. You could do a tree diagram if you'd like to. That he draws blue marble. Okay, blue marble. It says blue marble. So here's my blue marble. That's the probability of blue. And it says probability of heads. Okay, there's heads. And heads is my H. Okay. and I'm looking to where they overlap. Well, blue and yellow make green, so that's they only overlap one time. Okay, they overlap here once. Here's my overlap where they make green. 1 out of what looks like 8. So this is 1/8 probability. So the probability of blue and heads is equal to 1 out of 8. Okay. Now, if we did this using multiplication, we could say that the probability of blue is 1 out of 4, because there's 4 colors. And I can say heads is 1 out of 2. And I can multiply together and get 1 out of 8. It ends up being the same thing. Okay. Again, pause, rewind, replay if necessary. What is the experimental probability that she will draw a red marble and flip tails? Okay. Now, experimental probability, that is based on our experiment. Okay, that is based on our experiment, and that's based on these 12 trials. Now, these 12 trials are listed here. Trial 1, trial 2, 3, 4, all the way to 12. So this is trial 1, 2, 3. Okay, so I'm looking for red marble and tails. So I'll highlight all my red marbles. Okay, red marble, red marble, red marble, red marble, and then I'll go back again and I'm going to highlight my tails. Well, every time I see an R. So R, tails, R, tails. The only time they show up twice, so the only time they show up for each one is they show up twice, 2 out of the 12. Okay, so my probability, experimental probability based on my experiment of red and tails is equal to 2 out of 12, which reduces to 1/6. This is the answer you want, not this one if you can reduce it. Again, if you do the percentages, I believe this is 16.6 repeating percent, and this one is, I believe, 12.5%. Okay, either one is okay, percentage or the fraction. Okay. It says, how would you explain the differences found between experimental and theoretical probabilities? This was the same question that was in your quiz, that you take home quiz. Okay. Theoretical probability is what you expect to get. Is what you expect to get. Kind of like the title of this unit. Okay. Experimental probability is what you actually get from trials or an experiment. Okay. Now there's differences amongst them. Okay. So that explains what they are. I need to explain the differences. Okay. They are different because, this is shorthand for because, they are different because experiments don't always follow theory, but get closer as more trials are counted. Okay. Now, since we expect this 1 out of 8 times, we only did this 12 times. So it might have gotten 1 in the first 8. We can check. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8. In the first 8, 1 out of 8. Okay. Now in the second half, I didn't get through all 8 trials. Okay. So it's pretty close. All right, number 4 says, the diagram below shows a pattern in Guston's basement. What is the probability that he would be standing on a polka dot section? So we're looking at this flooring, and we're looking for polka dots. So this is my desired section. Okay. my polka dot section, we're looking for this section. Not just that polka dot section, but this polka dot section, and this polka dot section. Now I see that's 3 parts, okay? 1, 2, 3. But I have to take into account that they all have to be the same size, okay? If they're not all the same size, then I can't make my ratios correctly. Okay, there's a couple of items here that I have to break down so they're all the same. This white space here, this white tile, okay, it's actually 2 sections. So if you look at it closely, if I drew a line right here, then I'd have equal spaces. These are now the same, so I can count this as 1 space, 1 space. And here too, there should be a line here as well. Okay, so I have 2 spaces, not just 1 section of striped spaces. Okay, so my desired, okay, so probability of polka dots, okay, is 1, 2, 3 desired. There are 3 spaces out of a total of 1, 2, 3, 4, 5. 1, 2, 3, 4 out of 4. Oh, sorry, 20. 5 times 4, which is 20. Okay. Now you can find the percentage. This would be 15%, or you can have 0.15. Again, no percentage on decimals if you leave it in the decimal form, or 3 to 20. Either one is okay. This last section down here says Ray has a spinner that's divided into 3 regions. The spinner, she spins the spinner 10 times and records the results on the table. Now there's a typo here. This shouldn't say 3 regions. It should say 2 regions. Okay, it should say 2 regions because it's only the light side of the dark side. Now what they're saying is there's a spinner. Okay, so there's a circle here, and there's a center, and we need to figure out where I can draw my lines that will represent this item here. Okay, now here it says 360 degrees. Okay, so what I'm going to do is I'm going to find the area or the fraction of the percentage, sorry, the probability of the light side, the probability of the dark side. So probability of the light side is 6 and a total of 10. Okay, 6 out of 10 spins because there's 10 spins. The dark side, probability of the dark side is the difference, 4 out of 10. Now in order to find how many degrees this is here, I'm going to multiply it by 360. Multiply by 360 for each one, multiply by 360, and then I'm going to figure this out. Okay, so I'm going to reduce a little bit. I'm going to reduce each section here. I'll cancel that out. I'll cancel that out. And I have 6 times 36. So, because I counted out those tens. So 6 times 36 equals 216. So this should be 216 degrees. Okay. Again, I'll cancel out these zeros here. And I'll do the same thing. I'll do 4 times 36. And that gives me 144 degrees. 144 degrees. If I add these together, I should get 360, which I do, and that makes my full circle. So what I'm going to do is I'm going to divide this into parts. Okay, I know 180 is straight across, so a little bit less. I know this is 90, so somewhere, this would be 90, this would be 180, so it's got to be somewhere over here. I'm going to call this the dark side. I'm going to call this the light side. Okay, so it says give the degree measure, and I got them right here. I'm just going to write them where they belong. Okay, my light side is 216 degrees, and my dark side is 144 degrees. Okay, there's your study guide. You will take your test today. Yes, you can use your study guide. Yes, you may use a calculator. No, you may not use your neighbor's paper. Okay, so you can use any homework that you might have. If you don't finish it, we will have time the other classes to finish. Just finish your study guide and get through whatever you can on the test, and you may go home and study and continue your test on the next